This is Physics 101, Forces and Equilibrium. Like I said earlier in my first video, if you are following me. Now this is a block of 20 kilogram, a mass. And this is your normal reaction, your weight, and your frictional force. If you're given any block like this on a level ground, on the ground level, the two forces acting on this block, it's your normal reaction and your weight. So you have this like this. So the reason why this block is stationary, if you're following me, is your normal reaction and your weight. And we have coefficient of static friction acting in between the block and the ground level. The coefficient of static friction is greater than the coefficient of kinetic friction. The coefficient of static friction simply means the friction that is responsible for this block being stationary. While for the kinetic is as a result when the block is sliding. Imagine from a block here, it slides down to point A, point B. The reason why this block can slide, block A can slide to block B is as a result of the coefficient of kinetic, not static. So, pertaining to this question, you'll be giving your coefficient of static. The coefficient of static friction you have here as 0.20. Force is equal to your coefficient of static friction multiplied by your normal reaction. So in this particular question, if you are given your coefficient of static friction and you ask to calculate to find your frictional and you have to find your frictional force. Using this formula, you have 0.20 multiplied by your normal reaction. So to get your normal reaction, you need to resolve the components. Like the last time I told you in class, that was last year, I said if you are resolving vertically, you have here as a positive, and you have here as a negative. You have your x-axis as your positive and your y-axis as your negative. So I'm going to resolve this component here. That'll be my normal reaction minus my weight equals to 0. So my normal reaction can be equals to my weight, and it's also equals to my mg. So I have my normal reaction in this state as my mg. So my m is 20 kilogram multiplied by my g, which is 10 meters per second square, and I will have it as 200 Newton. So in this question, your frictional force is your coefficient of static friction multiplied by normal reaction, and you will have it as your coefficient of static friction, like I said earlier, was 0.20 multiplied by a normal reaction, 200 Newton, and if you do your calculation, you have it as 440 Newton rather. So that is your frictional force. So my frictional force here is 40 Newton. Now when this frictional force is 40 Newton, this states that this block cannot move without an external force that is greater than 40 Newton. Imagine I'm to drag this marker here, and I want to drag this marker here. So this is my force, external force. This is a marker here. So the frictional force holding this marker is this particular force holding it like this. So if I were to drag this marker and I want this marker to move to my right hand side, my force, which is this force, must be greater than this frictional force. Okay. So my frictional force is 40 Newton like I did last time, which was the last question. So if I want to resolve this particular component for this particular block, just normal resolution of component I explained earlier is your positive, your negative, my right hand side for x-axis, my positive and my negative. Here, as usual, my normal reaction is equal to my weight. I explained that earlier. Now, resolving this component vertically in a vertical reaction, I will have my force greater than what? My frictional force, or my force plus F minus frictional force, and that will be equal to 0. So my force is equal to my frictional force, and don't forget my frictional force, the other one was 40 Newton. So I will have my force to be frictional force, which is equal to 40 Newton. So therefore my force is equal to 40 Newton. This force, making it 40 Newton, simply implies that the reason why this block will still be stationary and at the point of moving is when my force is equal to 40 Newton. So I'm saying that this force having the value as 40 Newton means this block is about to move at this point. So imagine I have a block here and my frictional force is 10 Newton and my force here is 8 Newton. I have my normal reaction, I have my weight. Regardless the size of this block can't move. Why? Because my force is not greater than the frictional force. So what will make my block move rather? That is when the force is greater. Imagine I have 15. If I have 10.1 Newton, it will move this block a bit. But when it is 10 and 10 Newton, whenever it is 10 and 10 Newton or any of the same force are of the same value, that means the block is about to move. As simple as that. When the force is lower than the frictional force, it's stationary, it's static. And when they are equal, it's about to move. But when it is greater, it's moving already. And that is why we have our coefficient of kinetic friction. Trust in the standard. So, look at this question. Here is my block, 20 kilogram. This block here, and my frictional force is this. I have my coefficient of static friction as 0.20 for this particular question. Your coefficient of static friction is always greater than your coefficient of kinetic friction regarding the question, depending on the kind of question you are given. So we are using 0.20, 0.20 for this particular question. Now look at this question. Your block is 20 kilogram and a force, a particular rope. This is a rope. This rope is tied to this block and to some particular degree, 30 degrees. So they are asked to calculate the force in this question. How do you go about it? You resolve the component as usual. You know, but they're going to resolve the component, we have this. I'll drag this down. And the last time I said, let me quickly recap this. On the resolution of components, you have your north, south, and you have your east, west. If you have something like this, here, you have my theta here. Like the last time I explained in tutorial, I said, if this is my force, my result here is very simple. For here, I will have it as F sine theta. And I'll have it as F cos theta. So if I'm going to find this value for here, that will be my F sine what? Sine 30 degree. And here will be my F cos 30 degree. So these are my two forces. Now I'm going to resolve the components, like I said. So to solve this component, to solve this particular question, you have your force here, unknown, and you have to find your force. So you resolve component as usual. My normal reaction is in the positive direction of my x-axis plus n minus my w acting downward. And I have this as my positive. This here is also my y-axis. So the y-axis I'm having my normal reaction, my w, and my f sine 30. That's how we resolve this to components. So I'll have my n minus w plus f sine 30 degree equals to 0. Why is it plus f sine 30 degree? It is f sine 30 degree because here on my ground level here, this side is my positive, while this side is my negative. So I have this. That is for the y-axis. And if I'm going to resolve for my x-axis, that is, I will have my f cos 30 minus my frictional force equals to 0. I have my equation 1 and my equation 2. So let's resolve and find out. So resolving the 30 degree. And this is the order f cos 30 degree minus frictional force equals to 0. So remember I said my frictional force is my USN. That is coefficient of static friction multiplied by my normal reaction. Here, if I will solve this to make my answer the formula, that is I have two particular variance, that is variable. And when I resolve this, I have my n, bring the 1 to the other side. And my w is my mass mg. and my mass is 20, my acceleration due to gravity 10, and I have 200 as my weight. So I substitute it here. That is, I have my n plus f sine 30 equals to 200. Now back to the second equation, I have f cos 30 minus frictional force equals to 0. And my frictional force is my coefficient of static friction multiplied by my normal reaction. And you know my US is what? 0.20. So when I substitute it here into this, I have it as 0.20 n. So I remove this, put this there, and from this I put my 0.20 inside. I have something like this. Bringing it back, bringing this to this side, I have my 0.20 Newton minus f cos 30 degree equals to 0. So I'm having this equation now, and I'm having this equation now. So I can make simultaneous equation using the elimination method or substitution method. So I'm having normal reaction, force and force. Back to the question. So when I resolve this, I make my n subject of formula, and I have this as equation 30. So I substitute my n into this equation. So my n here, put inside here, I have my 0.20 open brackets, my 200 minus f sine 30 degree close bracket minus f cos 30 degree equals to 0. So multiplying this with this, I have this. So I have my 0.20 multiplied by this. I have my value as this here, that one like this, and I have this. So I have my F equals to 41.41 Newton. So that means if you look at the question, the diagram, which is like this, resolving the components we have on this. So when I substituted my F, my force, which is this, to my N, which is equation 3, this equation 3, I have my N equal